This is R.D. Sharma solution, class 12th. Adjoint and inverse of a matrix, chapter 7. We are taking very short answer questions, VSAQ. If A is a square matrix of order 3 such that adjoint of 2A. So square matrix means the rows and columns are same. So this is order 3. So 3 rows and 3 columns. And this is given that adjoint of twice of A is equal to K into the adjoint of A. Then we have to write the value of K. Okay. So we already know by our previous discussion that this adjoint of 2A is given. But if this 2 is some lambda or some K, so adjoint of lambda into A is equal to the lambda or K to the power n minus 1. And then adjoint A. Okay, in this case we will put lambda equals 2, and in place of n we are going to replace it by 3, and of course we have the lambda raised n minus 1 followed by adjoint of A. Okay, so adjoint, then this I am writing as 2A, lambda we are writing 2 again, and n is 3, 3 minus 1 is 2. So adjoint of A. Okay. So 2 square is 4, adjoint of A, and then we have on the left hand side adjoint of twice of A. Now please in the question please witness that adjoint of twice A is given as is equal to K adjoint of A. So why not to equate these two? Let us equate it, because this is already given in the question. So I am just equating it here, adjoint, or writing it here so that you can see the equality. Adjoint of 2A is equal to K into adjoint of A. Now from these two equations, K is equal to 4, K is equivalent to 4. So you can just write K equals 4. If A is a square matrix, then write the matrix adjoint A transpose minus adjoint A transpose. Okay, so let me tell you, there is when we are discussing the theory, I told you that the determinant of A when it is not equal to 0, that means we have the non-singular matrix. So the adjoint of A transpose, that is, you take the A transpose and then find out the adjoint, or you can find out the adjoint A and then you can transpose. Both of it are equal. When you take it on the left hand side, it is going to be not 0 but null matrix, because these two are actually matrix. So adjoint of A raised A transpose minus adjoint of A whole transpose is equal to null matrix, because these all are matrix. So the answer will be null matrix here. Null matrix is all about zeros. There is nothing in the matrix. All values are 0. Null matrix. If A be, let A be a 3 by 3 square matrix such that A into adjoint A is twice of identity matrix 2i, what is the value of determinant of adjoint A where I is the identity matrix? So this question, type of question we have already done, and when we know that the matrix A of order n, the A multiplied or A dot adjoint of A is equal to determinant of A, and then I n subscript is showing that what is the order of the matrix. It can be 3, it can be 2. In this case it will be 3 in this case. Okay, so adjoint A determinant we have to find out, but we know the value of this. From this we can relate to the question. The question is saying A into adjoint A is equal to twice of I. Since we already know this equation, we can equate these two equations, one in the question and one which we already know. A dot adjoint A is equal to determinant of A into In. So I am writing now what is given. A into adjoint A is equal to twice of I. Now if you see here, we equate a determinant of A is equal to 2. This is already given. So now determinant of A is 2. Now we already know that the determinant of adjoint A is nothing but determinant of A raised to the power n minus 1. We have already done a question like this in this exercise. So determinant of A is 2. Order is 3. So 2 raised 3 minus 1, that is 2 square, is 4. If A is a non-singular symmetric matrix, write whether A inverse is symmetric or skew symmetric. Okay, we have already seen a question like this. Again, let us revisit this. Now, A is invertible only when the determinant of A is not equal to 0. So, A inverse only exists when the determinant of A is not equal to 0. Okay, and this question is saying that A is a non-singular symmetric matrix. What does symmetric matrix means? A transpose will be original matrix A. That is symmetric matrix. If it would have been skew symmetric means A transpose is negative of A. Right? So A inverse transpose is equal to A transpose inverse. This already we know. This is a property. A inverse transpose is AT transpose. So AT is A. So let us write A here. So this is going to be, I am writing A transpose as A. So A inverse. So when you take the transpose of A inverse and you get in return A inverse only, that means this A inverse is nothing but the skew symmetric. If it would have been a skew symmetric, that is A inverse transpose will be equal to minus of A in A inverse. But since we get this in the equation, this is symmetric matrix. Now A is given this matrix and also A into adjoint A. I'll just tell you what this exactly, the question is. I'll just write it because there is a slight change here. I'll just write it. So first let us concentrate on this A. A is, we are interested in finding out K. But let us go with A and we need to find out the determinant of A just to show that A inverse exists. Then only we will be able to solve this. Because eventually we are going to find out we are going to multiply it with A inverse. So determinant of A is simply cos square minus sin square minus plus will be. So because there one is negative. So cos square plus sin square theta here. Okay. So this is going to be 1. Determinant of A is equal to 1. So since it is not equal to 0, we can easily say and safely say that this is showing us that A inverse exists. Now A inverse, we know the formula already. A inverse is adjoint of A and divided by determinant of A. This is a standard expression we know. Determinant of A is already 1, so we can just write A inverse is equal to adjoint of A. Now what we'll do here is, as I said, we need to tell that A inverse exists. Now we will multiply both sides by A. Determinant of A is 1, so we are just not taking that, one won't affect. So A into adjoint A it is. So A into adjoint A, let me write it here as I just told you. It is A into adjoint A. This is like this. So we need to find out A into adjoint A. For that we need to multiply A on both the sides just to get what is required in the right hand side. So since this is available to us and A into adjoint A we want, so we'll multiply both sides by A. Now this right hand side we already got because already given it is K 0 0 K. On the left hand side A into A inverse is what? It is identity. It is identity matrix. So we can just write it as 1 0 0 1. The diagonal should be 1, others should be 0, and you just equate it K equals 1, K equals 1. So this is your K. If A is an invertible matrix such that this determinant of A inverse is equal to 2, find the value of a determinant of A. So the question we have already done, and the A inverse, if you take the determinant A inverse, it is going to be 1 by determinant of A. This is as simple as when the determinant of A exists, 2 inverse you can write it as 1 by 2. This is just like that. Because determinant A is all about value. Okay. So this the value is A, the determinant of A inverse is 2. So you can write it here, 1 by determinant A. The determinant of A will be, take 2 on the right hand side, it will be 1 by 2. This is your final answer. If A is a square matrix such that A into adjoint A is this matrix, this is basically a scalar matrix, you can take 5 out, that will be an identity matrix. So 5 into I it is. If you multiply 5 to the identity matrix, you will get this matrix. Then write the value of determinant of adjoint A. So A into adjoint A is already given in the question. And since we can just write it as 5 into I as I just suggested you, if you take 5 outside, it will be 1, 1, 1 in the diagonal, and that is essentially equal to the identity matrix. So determinant of A into, because A into adjoint of A is determinant of A into IN. We have just seen in the last questions, few questions we have done. So determinant of A into IN is equal to A into adjoint of A. So determinant of, now you can equate this, determinant of A into IN. So determinant of A is 5 here. Okay. Now in order to find out the determinant of adjoint of A, what do? We know the expression determinant of A raised to the power n minus 1 and is the order of the matrix. And since we can see that the matrix is 3 by 3 square matrix, so n you just put 3, in determinant of A you put 3, 5 raised 3 minus 1, 5 square is 25. This is your answer. If A is given this matrix and it is such that A inverse is equal to K into A, then find out the value of K. Since A is given, in order to actually work with A inverse, you have to tell precisely whether A inverse exists or not. For that, you have to find out the determinant of A. When you find out the determinant of A is what? It should not, determinant of A, if it is not equal to 0, then we can say it is showing that A inverse exists. So 2 into minus 2 minus 5 into 3. So minus 4 minus 15 is minus 19. This determinant of A is not equal to 0. So we can say A inverse exists. Okay. Now we know that we multiply A with A inverse, you get the identity matrix. If you multiply this A inverse equals KA, and then you multiply this A, see A inverse into A is I, you know it, but we are going to deal with the question. So A inverse into K, let us multiply both sides by A, because A inverse you can replace it by K anytime. So I am replacing A inverse by K. So what do you have to do? You have to find out the A square. These two matrices you have to multiply because we have to find out A dot A. So when you multiply these two matrices, let me directly write the answer. I'm not going to do this because it's simple. 2 by 2 matrix multiplication you might have done a million times now. So K into this I am just writing K. A square I am writing as 19, 0, 0, 19, and this is equal to identity matrix, equate it with 1, 0, 0, 1, and then you can take 19 common from here because this matrix is simply a scalar matrix of 2 by 2 multiplied by 19. So you can take 19 outside and you can write this identity matrix 1, 0, 0, 1, and right hand side you have an identity matrix, so you can just cancel it out. Means if they are equal, it's simply you can cancel it out. K into 19 is equal to 1, so K will be equal to 1 by 19. So this is your K. K is 1 by 19 here. Let A be a square matrix such that A squared minus A plus I is equal to the null matrix 0. It is not 0, it is actually null matrix. Then write A inverse in terms of A. So all these type of questions we have done, and we have seen that the trick is to multiply the whole equation by A inverse. So the only thing is that you have to multiply both sides by inverse. So I'm multiplying this by A inverse. Here also A inverse into 0, anything multiplied by null matrix is going to be a null matrix, so you can just write 0 here. It is not 0, remember, I am just saying 0, but it is a null matrix. A inverse multiplied by A square, so A square is A dot A, you can just cancel these two out. It is basically identity matrix. A inverse into A is not cancelled, it is identity matrix. Again A inverse into A is identity matrix plus A inverse into I. Okay. Now A inverse into I, if you multiply anything with identity matrix, you get the same matrix back. So A inverse I, take other things on the right hand side. Null matrix we don't deal. I minus AI. So A into I is again A, because anything multiplied by identity matrix you get the same matrix back. So what do you get? I minus A. This is your final answer. Okay, this question we'll take up in the next discussion. Till then, thank you so much. Take care of yourself.